This is going to be lesson 2.4, the last lesson in this unit. So a hill and a gondola, they lie, gondola lies 20 feet above the ground and goes up the hill both. They both have a slope of 1/2. All right, so if we have a hill, all right, and then we have our little gondola tower. All right, so it's right here. You guys are maybe we're at the ski slope. They're both going up at the same rate. They want to know what is the relationship between the hill and the gondola line. They both have a slope of 1/2. So what does that mean? What can we say about those two lines that we drew? Anyone have any guesses?
They're parallel?
Yeah, they are parallel. All right, so we could throw that in. So the big idea behind this section are lines that have the same slope are parallel. All right, and I think that's kind of right, that's all we need, right? We can go home. Lesson's over. No. Suppose another line for the chairlift is placed at a constant distance c below the gondola line. Here is the equation, or what is the equation of the new line? All right. So the equation of our wire that the gondola is hanging from is 1/2 x plus 20. All right, the 1/2 is our slope. We use m for slope, so m is 1/2, and our b value is 20. That is our y-intercept. All right, and then the hill has the equation y equals 1/2 x. If you wanted to, you could say 1/2 x plus 0 because it is 0 feet above the ground. They want to know what this equation would be. If we just kind of look at the bottom of the gondola, what would that new equation be? All right, so this has a height. We don't know what the height is, but it is c feet below the gondola. All right, so this is kind of a weird one, but if we take the guide wire equation, so that's why, if we take that guide wire equation, that is 1/2 x plus 20, y equals 1/2 x plus 20. That's the wire. We know the gondola sits c feet below this guide wire, so all we need to do is just subtract c from it. All right, and that is going to be the equation of how high off the ground the chair in the gondola is, after a certain amount of time or after a certain amount of distance. Again, we don't know what c is. Maybe c is 5 feet below the wire. Maybe it's 10 feet below the wire. We don't know. We just know it's c feet. So we're going to leave it as a c value. All right. So theorem 2.13. You don't need to remember 213 if you're citing it. You can just kind of use the idea. So two non-vertical lines. All right, so two non-vertical lines are parallel if and only if their slopes are equal. So remember that if and only if, that was P with a double arrow Q. All right, so you could say two non-vertical lines are parallel if and only if their slopes are equal. So if you wanted to break that up, you could say if non-vertical lines are parallel, then they have the same slope. Or you could say two lines have the same slope, mean they are parallel. Also, any two vertical lines are always parallel. They go straight up and down, so those lines will always be parallel. So that's really all the theorem is saying. And remember, we use arrows to show that lines are parallel. All right, it's pretty easy to see vertical lines are parallel. But non-vertical lines, diagonal lines, I guess, if you will, if they have the same slope, then they are parallel. All right, so sometimes you'll be given a graph, all right, and they're going to ask, hey, are these two lines parallel? So look at K and N. Well, if it's on a graph, we can do that pretty easily. All we need to do are find some nice points on the two lines and figure out their slopes. If you look at the line, there's a nice point. It crosses at a lattice point, those not as dark kind of gray lines where it crosses right in between the two. How can we figure out the slope of line K? What can we do?
The rise over run.
Yeah. So our slope is our rise over the run. So there is the slope formula. We could use that, but sometimes it's just going to be faster to count. So if you make a triangle and look at that line, we are going down, count the spaces, 1, 2, 3, 4, 5. We're going down 5. So whenever you go down, that's a negative number. And then whenever you go to the right, that's a positive number. So we go to the right 4 spaces. So the slope, so we say the slope of line K is equal to negative 5/4, whereas the slope of line N, let's find 2 more nice points. So you get a nice point right here, you get a nice point right here, make your triangle, you're going down 4, and then to the right 3. All right, so are those parallel, yes or no?
No.
Definitely not. They do not have the same slope. How about lines M and Q? Find some nice points. We got M. So the rise on this one, you're going up 1 to the right 3. So the slope of line M, that's kind of weird that we have a 2M. Slope of line M is rise is 1, the run is 3. So the slope is 1/3 on that one. The slope of line Q, find your nice points, going up to the right 5. So that's 2/5. All right. So those are not parallel either because they don't have the same slope. They're not the same. I apologize for my handwriting. I know it's not the best on this touchscreen, but it is what it is. So line M and line Q, we say are not parallel. All right, here's another one. We kind of talked about both of these on that first day of school for that like algebra review. Perpendicular lines. Now again, don't feel like you need to memorize 2-14. Two non-vertical lines are perpendicular if and only if the product of their slopes is 1. All right, now that seems kind of confusing. You could say the products of their slopes are -1, or another terminology we have is opposite reciprocal. I don't know how to spell reciprocal, so we are going to abbreviate it. All right, so opposite reciprocal. An example of that would be if you have 3/4. All right, the opposite reciprocal of that is reciprocal means you're going to take the fraction and you flip it upside down. So you're going to have 4/3. And then the opposite means whatever the sign is, you're going to change it. So that 3/4 is positive, so that means the 4/3 needs to become negative. All right, and if you look, if you multiply those together, so the product, remember product means multiply, 3/4 times -4/3. You multiply those two things together, you're going to get -12 over +12, which simplifies down to -1. So the product of those two are -1. All right. Part 2 says a vertical line and a horizontal line are perpendicular to each other. That one's pretty easy to see. Those make right angles. Remember, perpendicular means a 90-degree angle or a right angle. All right, so now are J and K perpendicular? Let's find out. Let's figure out the slope of J. Line J. So here is our line J right here in green. Let's find nice points. That's always going to be the key, is finding 2 nice points here. So that's going down 3, to the right 2, and then line K. All right, line K is going to be this line right here. All right, so we got a nice point right here. Another nice point right here. So the slope of k is equal to, we're going up 2 spaces and to the right 3. So if you want to, you could think, are these two lines opposite reciprocals of one another? If you're good at seeing that, if you're good at identifying that right off the bat, you could say, yes, they are opposite reciprocal. If you take one, flip it upside down and change the sign, it's going to look like the other. But maybe you're not as good at seeing that. You can always, your surefire way of checking is to multiply them together and see what you get. So -3/2 times +2/3, that gives you a -6/6. Right? Remember, when you multiply fractions, you just go straight across. And -6/6 simplifies down to a -1, which is what we wanted. Our theorem says if you multiply them together and you get a -1, that means they're perpendicular. So we could say yes. You could say line J is perpendicular. Remember that upside down capital T? That means perpendicular. Perpendicular to K. My computer's about to die. Give me 1 second here. That'd be really bad if my computer died during class. All right. Okay, let's do part A. So H and L. So here is line H. All right, line H is right here. Line L is this one right here. So those are the two lines we need to compare. All right, so let's do the slope of H. Slope of H. Find two nice points on H. That looks like a nice point right there. And so is that one. So make your triangle. So the slope, you're going down 2 to the right 3. So your rise over your run is -2 over 3. The slope of L, all right, looking for two nice points. Got one right here, and one right here. Rise over your own. 1, 2, 3, 4, 5. Remember, count your spaces. So you're going up 5 spaces, and you're going to the right 2 spaces. So multiplying those two together, you got -2/5 times you got -2/3 times 5/2. You can already see that they're not perpendicular because the numbers aren't even the same. One's got a 3, the other one doesn't have a 3. That gives you -10 over 6, which simplifies down to -5/3. All right, so that does not equal -1. So these two lines are not perpendicular. And then K, part B, that's the same thing. Lines K and M, are they perpendicular? We don't have to do that one. K and M, they don't look perpendicular, but you should confirm that for yourself if you would like. All right, so I got 3 more slides for you here. What is an equation of the line through P that is parallel to L? All right, well, we know parallel lines need to have the same slope. All right, so our line's going to look something like that. So what should the slope of our new line L be?
1/2.
Okay, so we know the slope of line L is equal to 1/2 because, yeah, if you look at sorry, this shouldn't be line L. I need another letter. We'll use K. Line L is already being used. So it needs to be 1/2 because the slope of the original line, yeah, is 1/2. Is up 1 to the right 2. Now, we have a formula, and you guys may or may not remember this formula, but we call it point slope. All right, you might want to write this formula down, the point slope formula. All right, so this formula is y equals m times x minus x1 plus y1. All right, so keep in mind point P is our x1, y1. All right, this y and this x, they're locked. All right, so they stay x and y. It's the only numbers that change are the m, the x1, and the y1. All right, so we can literally plug in everything we know. We know the slope. The slope was 1/2. All right, so our equation is going to be y equals 1/2, and then keep everything else the same. The x stays x, the y stays y. So x1 ended up being -4, or -4, right? Because we have a positive 4 here, plus y1 ends up being a 1. So that is the equation of line K that passes through point P that is parallel to line L. If you want to, you could distribute this in. I know you guys like the y equals mx plus b formula. So if you wanted to go from point slope to y equals mx plus b, this would be 1/2 x minus 2 plus 1, which simplifies down to y equals 1/2 x minus 1. All right, so this one down here, this is your slope intercept form, your y equals mx plus b. All right, and then this one right here, this is your point slope. I don't care which one you use. If you like slope intercept, use that one. If you want to leave it in point slope, totally fine. It does not matter. These are the same exact thing. I think point slope's a little bit easier. But, you know, knock yourself out. I'm sure you guys all saw that TikTok of that girl asking what y equals mx plus b even means or where it comes from. So if you want to use this one, go for it. All right. What is the equation of line through P that is perpendicular to L? All right. So perpendicular, we need to use that opposite reciprocal slope. So we know the slope of line L. All right. The slope of line L, again, is 1/2. All right. So if we get the opposite reciprocal, what is the opposite reciprocal of positive 1/2? Anyone want to take a stab at it?
-2.
Yeah, exactly. -2. Or if you want to, you could say -2/1. So the perpendicular slope, right, capital upside down T, you could say -2/1. Right? You don't need that over 1 if you don't want to, but I like putting it in there. But again, not necessary. So now, using that point slope formula, y equals m times x minus x1 plus y1. All right, we have our x1, y1 here. Plug in everything you know. All right, so we get y equals, we're going to keep everything the same except for x1, y1, and m. So we have -2/1 x minus 4 plus 1. All right, so again, this is your point slope. So if you wanted your slope intercept, distribute the -1/2 n, and you're going to have, I'll do that in a different color. You're going to have y equals 2x plus 8 plus 1, or simplified further, you got y equals negative 2x plus 1. That is your slope-intercept.
It would be +9. Right?
Say that again. Dang it. Sorry. Yeah. There we go. That's what I meant. You misread it. So what we can do is we could graph this starting at this point. We know the slope. We have to go down 2 to the right 1. So we're going to end up, I'll do this in red. Right. Our equation is going to look something like that. And if you look, that makes us a nice 90-degree angle. So that is the equation of the perpendicular through line L. All right. Again, I don't care which one of these you give me because they're literally the same thing. All right. I think I got one more for you here. What are the equations of lines parallel and perpendicular to the given line passing through point T? All right, so this is literally going to be the same thing, except there's no graph this time. So we know the slope equals, right, we got y equals mx plus b. I don't really care about the b value, but the slope in this case is -3. So what that means is the perpendicular slope, remember you could call this -3 over 1. So the perpendicular slope, you're just going to take that first one, flip it upside down. If it's negative, make it positive, and you're going to have positive 1/3. And keep in mind this is our point x1, y1. So plug in what you know. So we'll do the parallel line first. All right, so keep in mind parallel lines have the same slope, so you want to use the original slope. So you're going to say y equals -3 times x minus x1, which in this case is a 3, plus 1. Right. And then if you wanted to simplify that, you're going to get y equals -3x plus 9 plus 1, which simplifies down to y equals -3x plus 10. So now, if you do the perpendicular one, same thing, except now we need to use this slope over here. We'll have y equals positive 1/3, and then in parentheses, x minus 3 plus 1. And then again, simplifying, you're going to get y equals one-third x minus 1 plus 1, which simplifies down to y equals 1/3 x plus 0. And since it's plus 0, you don't even need that. You could just say y equals 1/3 x. Right. Same thing. But again, in either situation, slope-intercept, and then these two are point slope. I really don't care which one you give me. If the directions ask for one, then just do that one. But if the directions don't say, then you can use whichever one you want.